Assalamualaikum and good evening to Dr. Teh and all of my friends. Today, we would like to present about application of area and length in polar coordinates. We are from Group 6.
For introduction, we have two parts, which is polar coordinate system and history of polar coordinate system. For polar coordinate system, we can understand that it's a two-dimensional coordinates system in which points are given by an angle and a distance from a central point known as the pole. Next, polar coordinate system also used in many fields, including mathematics, physics, engineering, navigation, and robotics. Polar coordinate system is a very useful in some of situations where the relationship between 2 points is most easily expressed in terms of angle and distance. Polar equation is the simplest means of representation for many types of curve. Next, we go to history of polar coordinates. For history of polar coordinates, it is known that the Greeks used the concept of angle and radius. There are various accounts of who first introduced polar coordinates as part of a formal coordinate system. The full history of the subject is described in Harvard's Professor Julian's Origin of Polar Coordinate System. In 1733 years ago, Sir Isaac Newton was the first to look upon polar coordinates as a method of locating any point in the plane. Newton examined the transformation between polar coordinates and the 9 others coordinate system.
Key concept: application of polar coordinate in real life. There are many examples of application of polar coordinate in real life. For example, analog clock, robotics, and aviation.
Next, application of area and arc's length in real life. There are many applications of the area and arc's length in real life, such as ferry wheels, bicycle wheels, and pizza.
Objective. Our objective is to determine area and length for some application problem using in polar coordinate system.
Every decision maker wants to make the best alternative to calculate the area and length. For find the best alternative in calculate the area and length for polar coordinates, there are method which is integral define method. First, we use area. Area is defined as the space by flat shape or the surface of an object in geometry. The area of figure is a number that covers the surface of closed figure. The measure for area is in square units, such as square centimeters, square feet, square inch, and others. The formula to calculate the area of polar coordinates is 1/2 integrate alpha to beta r square differentiate theta. Second is length. Length is the term for identifying the size of an object or the distance from one point to another point. It is a measure of how long an object or distance is. The different units of length are meter, millimeters, centimeter, and kilometer. Arc length is distance between 2 points along a section of a curve. The formula of arc length in polar coordinates is integrate a to b square root r square plus differentiate r with respect to theta with power of 2 and differentiate with theta.
Example and analysis. Example 1. A circular coral of unit radius is enclosed by a fence. A goat inside the coral is tied to the fence with a rod of length 0 until 2. Based on the figure, what is the area of the region inside the coral that the goat can graze? Check your answer with the special case A equal to 0 and A equal to 2. We can see that from the figure, we need to determine the area of the region that area of the goat can graze, they are given that the radius of the circle is 2. So from the equation, we can get two equations, which is R1 equal to A and R2 equal to 2 cos theta. Since S equal to R cos theta, we know that the area that the green are between the limit of 0 to the intersection between the first circle and the second circle. The intersection between the first circle and the second circle, we can determine the angle, which is we are substitute R1 equal to R2, which is A equal to 2 cos theta. Then we can get cos theta equal to A over 2. Then we get the degree of the angle, which is cos inverse A over 2. Therefore, the area that the goat can graze is when we add the green area color with the area of the pink color, since the both area are the same. We just need to calculate only one part and multiply it by 2 to get the whole area that the goat can graze. So, we can see that the area of the goat can graze is 2 multiplied by integration of 1 over 2 R1 square d theta with the limit 0 until cos inverse A over 2, which is the cos inverse A over 2 we can get from the intersection of the first circle and the second circle. Then we plus it with 2, that we multiply it with the 1 over 2 R2 square d theta, which is the limit is from cos inverse A over 2 until pi over 2. Then we substitute A into R1 and 2 cos theta into R square. Then we take out the A2 from the integration. We can get A square integration of 1 d theta from 0 until cos inverse A over 2 plus integration 2 cos theta square d theta from cos inverse A over 2 until pi over 2. Then when we integrate 1, we can get theta. So for the first area, we can get A square theta with the limit 0 until cos inverse A2 plus 2 cos square theta d theta with the limit cos inverse A over 2 until pi over 2. We can get the first area is A square cos inverse A over 2 plus 2 integration of 2 cos square theta d theta from the limit cos inverse A over until pi over 2. By using trigonometry identity, we change 2 cos 2 theta into cos 2 theta plus 1. Therefore, the area will become A2 cos inverse A over 2 plus integration of cos 2 theta plus 1 d theta with the limit cos inverse A over 2 until pi over 2. Then we can get A square cos inverse A over 2 plus 2 sin 2 theta over 2 plus theta with the limit cos inverse A over 2 until pi over 2. We substitute the value of the limit and then we can get A equal to A square cos inverse A over 2 plus 2 with the bracket sin pi over 2 plus pi over 2 minus with the bracket sin 2 cos inverse A over 2 plus cos inverse A over 2, close the bracket. Then we can get the area is equal to A square cos inverse A over 2 plus pi minus sin 2 cos inverse A over 2 minus 2 cos inverse A over 2. Then we simplify the answer, then we get area equal to A square minus 2 with the bracket cos inverse A over 2 plus pi minus sin 2 cos inverse A over 2. Therefore, based on the question, we can see that ask us to check the answer with the special case A equal to 0 and A equal to 2. When A equal to 2, we can get the maximum area that the goat can graze, which is A equal to 2 square minus 2 cos inverse 2 over 2 plus pi minus sin 2 cos inverse 2 over 2. We can get the area equal to pi or 3.142. When A equal to 0, we can get the minimum area that the goat can graze, which is A equal to 0 square minus 2 cos inverse 0 over 2 plus pi minus sin 2 cos inverse 0 over 2. And we can get the area equal to 0. Therefore, the area the goat can graze are between 0 until 3.142 unit square, with the length of the road is between 0 and 2.
Next, example 2. We need to find area and length. The musician want to know the area they will have on stage within the optimal pickup range of the microphone and the arc's length of the area.
For this example, we use quadratic formula to find the value of theta. We substitute the value of A, B and C into the formula to get the value of theta. After we substitute the value of A, B and C, we simplify until we get the value of theta, which is sine inverse negative 1 plus minus 3 divided by 2, but we ignore the value of negative 3 because have no solution. Then we just take theta equals to sine inverse negative 1 plus 3 divided by 2. Then we simplify until we get the theta, which is theta equals to 0.374734 radius. We also must find the second limit of theta, which is pi minus 0.374734. Then we get 2.76858 radians. After we get the two value of theta, we can find the area using the formula for area. The limit of theta, we can use the second limit that we find just now, or use pi divided by 2, but we must multiply the equation by 2. In this case, if we use a limit 0.374734 until 2.76858 or 0.374734 until pi over 2, we can get the same answer for area. After we apply the limit, we substitute 8 plus 8 sin theta for f theta and 4 divided by sin theta for g theta into the formula. Next, we integrate the equation until we get the value of area, which is 204.16 unit square.
To calculate the arc length of the area, from the question, we can get equation R equal to 8 plus 8 sin theta. We have to use arc length formula to solve this question. Firstly, we need to calculate the R squared. Second, we have to differentiate R with respect to theta. Third, we need to calculate the power 2 of differentiate R with respect to theta. So, substitute all the value into the formula of the arc length with A equal to 0 and B equal to 2 pi. And the answer is 45.2548 meter. Therefore, the boundary of the optimal pickup region is given by the cardioid R equal to 8 plus 8 sin theta, where R is measured in meters and the microphone is at the pole. The arc length of the area that the musician want to know is 45.25 meters that they will have on stage within the optimal pickup range of the microphone.
As a conclusion, techniques for problem solving are very important. It has helped one in determining the area that have been desired and those that are needed.